Am I audible?
Yes, you are audible. You can start.
Very good morning to all. I, Mr. Prashant Payam, welcome all the participants for the national webinar on optimization techniques for engineering, which is organized by Sanathana Research and Training Institute, a unit of Sanathana SAMPRATHISHTANA, Mysuru, in association with the Rotary Club of Mysuru West. So prayer is the process of talking to God in order to achieve a purpose. So let us begin this webinar by seeking the blessing of the Lord Almighty. Vakratunda Mahakaya, Koti Surya Samaprabha,
Nirvignam Kurume Deva,
Sarvakareshu Sarvada. Now, I request Dr. Ramachandra Seji, the Managing Director of Sanathana Research and Training Institute, to welcome and introduce the speaker of today's webinar. I also request him to welcome the guests and participants. Over to you, sir.
A very good morning, one and all. I take this opportunity on behalf of Sanathana Research and Training Institute, which is an unit of Sanathana SAMPRATHISHTANA, Mysuru, to welcome today's speaker, Dr. P. Sivasankaran, Associate Professor, Manakula Vinayagar Institute of Technology, Pondicherry, and today's guest, Dr. Raghavendra Prasad, MD, President, and Sri Dinesh Kumar, Secretary, Rotary Club of Mysuru West, and participants from different parts of the country. So the vision of the institution is to lead the frontier of educational training and research activities on an international tier. The mission of our institute to develop necessary skill set among pupils of all educational hierarchy, to train the tutoring fraternity on various educational forefronts, to conduct in-house research activities on an industrial scale. The main objectives of our institutes are to train pupils with necessary skill set by conducting various programs, to train tutors in various upcoming educational domains, to empower training fraternity on various research platforms, to enhance and conduct research activities in various domains, to provide financial aid to the certain group of society, to empower them with necessary skill set, to conduct programs on various societal needs. And coming to today's the speaker, let me introduce him. So Dr. P. Sivasankaran has obtained his BE degree in mechanical engineering from Pallavan College of Engineering, Kanchipuram, and ME in industrial engineering from Tyagaraja College of Engineering, Madurai. He has obtained his PhD in industrial engineering from Anna University in the year 2015. He is having a total 10 years of teaching experience in various cadres and currently is working as Associate Professor at Manakula Vinayagar Institute of Technology, Pondicherry. Dr. P. Sivasankaran has published a total 35 papers in reputed international and national journals and also presented many papers in international conferences. He has published books on quality management, process planning, and cost estimation, managerial economics, and computer integrated manufacturing, automation for excellence, etc. He has organized 15 workshops and guest lecturers on recent technological advances in the area of industrial engineering. He is a peer reviewer and editorial board member for various reputed international journals. He is a life member of Indian Institute of Industrial Engineering, Mumbai, IAENG USA, and Teaching and Education Research Association, Eurasia Research. Is proficient in software such as design for assembly, AutoCAD, RoboDK, etc. He has guided various academic projects for UG and PG students. He is regularly applying for projects, seminars, grants, FTBs, HTTPS under various schemes of DST, CSIR, NS&TM, and ASCTE. He has carried out a novel research on the work titled Comparison of Jute and Sisal Fiber Reinforced Composites using Crust PCB with the support of C Intel Services, Chennai. He has actively participated in various FD-based national and international workshop, HTTPS, at various institutions. He has delivered guest lectures at the institutional level and also at reputed industries in the topic related to software applications and other industrial engineering areas. So the beautiful thing about the learning is that nobody can take it away from you. So that's why never stop learning. When we stop learning, then we stop growing. So learning gives us the creativity. Creativity leads to thinking. Thinking provides knowledge, and knowledge makes you great. So knowledge is divine. Knowledge is powerful and it should be shared. So this knowledge sharing, the platform we have created today. So the today's topic, the optimization, is nothing but it is an act or the process or methodology of making something such as a design, system or decision as fully perfect, functional or effective as possible. Specifically, the mathematical procedures such as finding the maximum of a function involved in this. So optimization techniques are useful in finding the optimum solution or unconstrained maxima or minima of continuous and differential functions. Today's national webinar on optimization techniques for engineering. So here the speaker will going to give the entire details about the optimization. He'll going to give the introduction about optimization and the concept with different examples and nature and property of optimization, and even introduction to linear optimization and different case studies of product mix problem using lingo solver mathematical modeling software. So that also you're going to highlight the scope of optimization including in simulation. So these are some of the main highlights the speaker will going to speak today. So with this, I wish all the participants will have a fruitful interaction with the speaker. Once again, I thank one and all. Over to you, Prashant.
Thank you, sir. Now I request today's guest, Sri Dinesh Kumar DK, Secretary, Rotary Club of Mysuru West, to say a few words about today's webinar.
Thank you, Prashant. Prashant, audible?
Yes, you're
Yes, sir,
audible,
yes, sir.
sir.
Okay. I must congratulate Sanathana Research and Training Institute for the organizing awareness webinar on optimization of techniques for engineering. It is badly needed nowadays. In optimization of a design, the design objective could be simply to minimize the cost and production or to maximize the efficiency of production.
Yes.
Actually, when I was in engineering, National Institute of Engineering student, at that time I did standardization of jigs and fixture and metal tool cutting design metal tools in Bemal. And coming to our Rotary Club, Rotary is the international organization meant for serve the society and helping hands to needy people. Total, we have 11,94,000 members from 36,350 clubs are there across the world. In India, we have 4,000 clubs and 1,55,000 members. We Rotary Club of Mysuru West, happy that we are associated with Sanathana SAMPRATHISHTANA. They organized a number of fruitful seminar, webinar during this COVID time. I once again thanks to Sanathana Research and Training Institute for inviting eminent personality Dr. P. Sivasankaran, Associate Professor from Manakula, Vinayagar Institute of Technology, Pondicherry, for speak on optimization techniques for engineering. I hope our participant will gain knowledge out of this webinar. I once again thanks and I wish you all the best for this webinar and good luck. Thank you. Thank you, Prasad. What to thank Prasad.
Thank you.
Thank you, sir. Now I request today's speaker, Dr. P. Sivasankaran, Associate Professor, Manakula Vinayagar Institute of Technology, Pondicherry, to start his session. Over to you, sir.
So very good morning to one and all present here. First of all, I welcome the respected organizers from Sanathana Research and Training Institute and my dear participant for today's workshop on optimization techniques for engineering. Myself, I am Dr. P. Sivasankaran, currently serving as Associate Professor in the Department of Mechanical Engineering, Manakula Vinayagar Institute of Technology, Pondicherry. So our today's agenda for the meeting. So first let us understand the general introduction. What does the term optimization means? Then few research literature survey, the past literature survey. So in that we are going to see about the concept of linear programming or linear optimization model in 4 major areas like manufacturing, civil construction unit, then food factories, then agriculture supply chain system. Since I belong to the mechanical engineering domain, so I have collected somewhat the related survey on engineering and other associated engineering fields. So with that, we will come to a final conclusion about the literature, review of literature on linear optimization. Then we will come to the problem definition, then followed by that, the case study with the example of a product mix problem, how optimization can be applied to find out the maximum total profit for 2 different product variety or 2 different models. If a unit profit for both the models are known well in advance, how will you arrive out or how will you determine the total maximum profit by combining the product mix P1 and P2 together? Then we will see the case study discussion by using Lingo Solver. Normally, graphical method, many people used to do it in operation research. There might be a subject, operation research, in 6th semester of mechanical engineering. Normally, students are expertise to use the manual methodology, graphical method for linear programming. But for a change, I am going to introduce Lingo Solver. Okay, so this kind of software tools will try to save the time in getting the result for particular real world problem within a less span of seconds, right? So conclusion of optimization in engineering. So this is going to be our last end of the statement, the conclusion. Okay, before closing, you will have the conclusion remark. And in between, just before conclusion, some future scope application in optimization, that is simulation and model building. Currently, people know mathematical modeling, structured equation modeling in engineering sciences, but simulation, virtual simulation, prototype making. Okay, so that is also another the opportunity in research and development the engineers are having. Okay, so with this introduction, now I will move on to the topic directly. So what does the term optimization means? As the organizer, Dr. Ramachandra says, so the optimization means selecting the best design alternative for a product in order to maximize the performance of the product in terms of increased efficiency. So you have so many parameters. So for a product design, so we want to select the best parameter out of available alternative. So for that case, we need to go for optimization, right? So it is said to be a decision-making process. So which constraint most suitable for the objective function? Okay, to start with an example, sheet thickness of a vehicle body frame, optimizing the sheet thickness of a vehicle body frame. Okay, so this is the problem objective, right? So accordingly, we need to consider the choice of material that would be lightweight in nature. If I want to reduce the thickness of the sheet metal, so the entire the body frame of the vehicle should be compactable, lightweight in nature, so that I can able to increase the standardization as well as the quality of the product design by using FEM, finite element modeling. Okay, so through that I can able to find out on trial and error method. So what is the most optimal sheet thickness value that will reduce the manufacturing cost of the material and also increase the quality of the product in terms of high aesthetic design, right? So this is one such example. So when I say optimization, that is nothing but some parameters you are going to set in order to work the given objective function for a problem, right? So next thing, essential features of optimization problem. What are the general common features of optimization problem? If you take any mathematical model in optimization technique, it may be non-linear programming or integer programming or linear programming mathematical model. So all will have an objective function that has to be optimized. The objective function can be of two categories. It may be of maximization approach or minimization approach. So when we have to go for maximization and minimization, that depends upon the problem scenario and the situation that is applicable to the engineer. So for example, economic objectives. Okay, so in that case, you have to use max or maximization. Okay, so maximizing the profit, okay, by reducing the manufacturing cost or a production. Okay, so we want to increase the profit by reducing the cost of the manufacturing. Okay, by having by increasing the sales, product sales by in high volume. So this is considered to be economical objective. Okay, technical objective. Okay, optimizing the product design and development stage according to the customer wish, right? So these are all the way in which we can channelize, we can preset the objective function before going to solve the mathematical modeling languages. The technical objectives are almost integrated with economical objective. So if I say that I want to optimize the design, automatically economical objective, cost will be saved, time, everything, the product, energy, the usability, that will be improved. So technical and economical objective are considered to be multi-directional, multi-objective function. Next, why optimization is highly essential in today's scenario? So the primary aim of optimization is to simplify the manufacturing process. For example, I want to do casting, a special forming process, rolling, extrusion. Okay, these are some of the special forming process in manufacturing background. So I want to reduce the cost. Okay, I want to simplify the manufacturing process by reducing the cost. Okay, with the cheap available material, then improving safety and reducing the human error. Okay, if possible, I can go by automation. Then improving the innovation and product efficiency. At last, consistency, reproducibility, giving same kind of the product without compromising with the quality by retaining the huge volume of customer. Okay, so for all such things, the optimization is one, the basic tool or a prediction methodology which takes care of all the supporting features. What are the steps, the general steps or procedure, a guideline, you can say guideline in optimization? First thing, you have to develop a process model using 3D CAD modeling software, okay, and do simulation by importing the 3D CAD model in, for example, you take HyperMesh or ANSYS. These are some of the simulation software, the product design analysis side. So you can import the 3D model, the process model. So you can do the simulation. Okay, take the simulation result and keep it ready. And many researchers will analyze whether simulation results alone will serve the best purpose or not? Definitely not. We have to use a substitute technique or methodology, that is none other than mathematical modeling, formulation of optimization problem using mathematical solvers or mathematical programming packages. Okay, so that act as a standby or a substitute tool to compare the results of the simulation. Okay, then solution, try to get the solution by optimization problem using those solver and review the optimization results obtained by mathematical modeling and select the best optimal solution, compare it with the simulation result. Okay, and find out the gap between the simulation methodology and the optimization approach. So this is the research trend goes on at present in PhD level. If you take mechanical engineering, okay, so welding characterization, simple example. I want to do research on characterization of welding. Okay, so I can perform a simulation study first, okay, and then I can do a mathematical analysis and compare the results with the simulation and try to find out the gap between the quantitative modeling and descriptive simulation modeling. Okay, right? Simulation will just give you the state of the system, the behavior of the real system. Okay, but it will not give you the correction factor. Okay, whereas optimization, the mathematical modeling software, so that will give you the correct result or an output on trial and error basis, right? So under which iteration that has the best yield output. Okay, right? So what are the various elements of optimization problem? So here I have presented the general canonical form of mathematical equation expression. So every optimization problem can be classified into 4 major elements: set of decision variables. Decision variable is nothing but an unknown variable. Here you take objective function min, that is minimizing. Okay, f of x is a function. So I want to minimize the function. So what is the function? Let us take an example. I want to reduce the cost of the material by selecting the best vendor supplier. Okay, so let us take a vendor selection as a problem. So I want to get the raw material at a very cheap quote. Okay, so I want to go for min function, min f of x. So this is the objective function where x is nothing but the unknown decision variable. So I may not be knowing the quality of the vendor and what type of the material he provides to the manufacturer when the order is being passed. Okay, so this unknown variable is influenced, supported by the objective function f. Similarly, constraints is nothing but the resource limitation or limiting criterion, we can say. So there will be a combination of equality type or inequality type constraint that depends on the resource we are going to preset in the while performing the model construction. Okay, right? So when you are solving, when we are discussing the case study today, we will come to know what type of constraint we are going to discuss in the case study, the product mix problem. Then the next thing, optimization by mathematical model. So even though there are several mathematical modeling approaches are available, so among which linear programming is one of the basic, most widely used popular tool in determining the proper allocation, optimum availability of resources. So the resource in an industry, you can take in an industry, availability of raw material in inventory management, financial backup or money management from the management side of the company, to propose a budget estimation to buy a new software or a machinery, even for a manpower recruitment. What is the salary wages in a financial year you are optimizing? Okay, then missionaries, right? So for all these areas, we can do optimization using linear programming approach, right? So linear programming is used in many real business case studies like financial management, production, manufacturing, sales, and personal management, HR management system, and many more areas within the industrial setup. So what is linear programming? A general definition. Okay, so it has a linear objective function which has been structured in the form of x1 plus x2 plus x3. Okay, so objective function min f of x, that is function of x1 plus x2, summation of f of x. So I want to sum up the individual unknown variable to solve the total objective function. So the objective function will be of linear in pattern. Similarly, constraint will also be in the same manner, linear in structure. So simple example to understand what is linear programming. So my objective is to increase the production output or organization productivity. So I want to increase the skills of manpower, the talent pool of the manpower. So that is my constraint, the manpower constraint, the skill set. So objective function is production output. So if I increase this, if I maximize the production output, automatically I can able to improve the skills of the manpower. So these two are having a proportionate relationship, constraint and objective. So every formulation, the mathematical formulation, both the objective function, the linear objective function and linear constraint should have a proportionate relationship together in order to have feasibility solution. Otherwise, if both are totally contrasting, so that will lead to error, infeasible solution. Okay. So properties of linear programming model. So the following are some of the standard properties as listed below. So every objective function and constraint should add up with a decision variable. So decision variable that will try to influence both constraint and the objective function. Then each mathematical model must have an objective or a goal function. Resource constraints are highly essential to solve the objective function, and non-negativity constraint that is most important. For example, let us say x1 greater than 0, x2 greater than 0. That is, what is x1 and x2? Let us take in this sense. How many x1 units of products you are going to manufacture? How many x2 products you are going to manufacture? So that should be always greater than 0. Okay, that is non-negativity constraint. So your model should not give negative objective function. Okay, positive objective function. Okay, so that is the general ideal representation, of non-negativity constraint. x1 comma x2 greater than or equal to 0. So now let us come to the research survey, the past recent research trends in engineering optimization by equipping linear programming model. As per article number 1, the authors have did the title of work. So this is the proposed title of work: application of linear programming model for production planning in an engineering industry, a case study. So in this case study, they took the objective as workforce, maximizing the workforce and optimizing the lot size of inventory. So multiple objective, not a single objective. Okay, so they want to maximize the workforce, the capacity of the workforce. At the same time, they want to have an hands-on control over the inventory management. So it is a multiple objective function. Okay, so they solved by using linear programming model. Okay, that is linear optimization model. So this work has been published in the year 2019. Then the second article, application of linear programming techniques in production planning. That is a demand for the production. Okay. So here the authors consider the optimum utilization of limited resources. They strongly focus only limited assignment of resource. Okay. So the production capacity should not be excess. Okay, there should not be overutilization at the same time underutilization. So it should have a medium or minimum economic order quantity. Okay, so to suit out the daily demands of the production shop floor. So they considered what is the daily demand requirement for the production shop floor. Okay. Based on that, the linear programming techniques are applied in the problem feed mill production company, right? So the same year, the article has been published. Then the third article, linear programming problems in engineering curriculum design. So this is from education sector. Okay, so every year the engineers, lakhs and lakhs of engineers are passing out from the educational institution, premier educational institution. So they, as an engineering college, they have to satisfy the industry demand by giving the best product to the company during the placement and recruitment time period. Okay, so the student quality should be meet out as per the industry demand by enriching the curriculum by more practical. Okay, instead of giving too much of theory, by more practical, enhancing more practical knowledge of the student. Okay, by minimizing the theoretical aspect. So in that way, the authors have tried, and what the industries are expecting. So by connecting both academia and industry relationship as a strong bonding. Okay, so this is considered to be a more dependable, okay, proportionable between industry and education. If the college increase the quality of the student, more number of students are placed in dream jobs. So the industry will be ready to take the people, the best asset from the premier institution. So they applied linear programming to cater the needs of supply and demand, to match the supply and demand, right? So the same year it has been published, 2019. The next, healthcare dietitian problem, optimal diet decision making problem using linear programming. Okay, so in this paper, the author considered the age group of 40 to 45 years. They took the person age of 40 to 45 years. They took various parameter modeling like sugar, BP, then the cholesterol. These are various parameters they studied under this age group, and they applied linear programming. So which should be controlled, which parameters to be controlled, based on which the economical living lifetime of the person can be enhanced much better. Through mathematically, they proved it, they solved it. Okay. The next, article number 5, optimizing profit with the linear programming model in a manufacturing, leather shoe manufacturing industry. Earlier, they used on trial and error method, that is without using mathematical model. They tried trial and error method. Okay, so that was not meaningful with respect to the output, so that lead to suboptimal results. Then later they realized the essence of quantitative modeling, okay, to find out what is the optimal requirement of the product, the shoes to be manufactured, okay, in a particular year, right? Then next, application in construction, civil sites. Okay, so in this paper, the author focused on linear optimization of assessment of material, okay, and used for civil construction, okay, based on the bidding strategy, tender notice, which supplier gives the least tender, okay, in order to serve the purpose, okay, by giving the valuable service, by enriching the quality of the material. At the same time, we can put a long-term contractual relationship between the civil constructor as well as the supplier, the vendor. Okay, the next article number 7, application of linear programming in inventory management system in a food factory, a bakery model. So here the author used simplex algorithm in linear optimization. So they consider the different demand of the customer. So they took the product as a loaf. So by considering different variety of loaf, big, small, and giant loaf, depending on the number of customers, how many number of customers opted for big loaf, giant loaf, and small loaf. Accordingly, they want to put different varieties in huge number for profit maximization. Okay, right? Then article number 8, agricultural operation. Direct energy optimization for sustainable agricultural operation using fuzzy linear programming approach. So here the objective is to maximize the crop cultivation depending on the quality of fertilizers used. That is the constraint. Okay. So when there is a different climate change occurs, so we want to identify suitable fertilizers to allow the yield of the crop to be maximized. Okay. So these are all the various the literature review in the recent past. Okay, the authors have conducted several literature review using the mathematical modeling, the quantitative approach. Okay, in various areas. So with this limited outset, so I hope the participant might have known the popularity of the quantitative modeling rather than simulation. So simulation will give you only near optimal solution or suboptimal solution. Okay, whereas the mathematical modeling, okay, that approach will give you the optimal solution for any engineering or non-engineering application. Now let us understand the precise meaning. What is linear programming? Generally, earlier slide, we saw what is linear programming. It has a linear model, a set of constraints. On that way, we have discussed, right? Now, the exact ultimate meaning of the linear programming, it is said to be a mathematical technique, a theoretical mathematical technique in which the linear function that can be either maximized or minimized, subjected to various set of constraints. So this kind of methodology used as a guiding tool in many real world industrial engineering problems. Let us say social and physical science. In physical science, human ergonomics, predicting the body motion of a worker within the industrial setup. Okay, I want to maximize the energy of the worker. Okay, so minimizing the human fatigue, right? So what is the minimal motion, the body motion expected, simple ergonomic motion expected by the human worker? Okay, so for such application also, LP modeling can be used. So now we will move on to the case study. Okay, how we can apply the software, the Lingo solver for this product mix problem. Okay, so you think as a consultant. Okay, so this is the problem which is given to the consultant in an industry. Okay, so you take a company manufacturer, two variety of product model. Let us take P1 and P2 respectively. Okay, each product requires processing the job on different machineries, milling machine and drilling machine. But each type of machines has limited hours, working hours per week. The net profit per unit of the product and the resource requirements of the product and availability of the resource are summarized in the next slide. So this is the data of the product mix problem, which is given in the table format. So these are the two variety of product model defined by P1 and P2 and total machine hours available per week. And these are the available resource which is given here. Okay, and the profit per unit for both P1 and P2 in rupees has been tabulated here. So let us read the data in such a way. So 2 hours, the process timing of product model P1 on milling machine requires 2 hours of time duration. Okay. Similarly, the product model P2 on the milling machine, it requires a time duration of 5 hours to operate, but a maximum working hours per week, 200 hours. So within that maximum peak availability period, we want to set the availability of working hours in order to process the 2 product models in the corresponding machineries. Same thing is applicable for the next one, drilling machine. 4 hours and 2 hours, the working hours to process the 2 model. Maximum limiting criteria is 240 hours per week. And what is the unit cost, unit profit, okay, for individual product model P1 and P2? Rupees 250 for P1 and 400 for P2. Okay, so how will you solve? Okay, so develop a linear programming model using Lindo package. So here the handy calculation, the mathematical handy calculation, conventional approach is avoided. So in the industrial scenario, the paper works people know they don't want. Okay, they want answer solution through software approach. Okay, right, within a less span of second. So for this problem, you have to develop a linear programming model using Lindo package, okay, which is an open source, free downloadable software, Lindo package. So determine the maximum profit of the product, the total maximum profit of the product. So that is the objective in this case study. Okay, now let us see the solution. So these are some of the notations. When you're writing a mathematical model, okay, first roughly in a paper, we will scribble the idea how to get a mathematical construction. Then only we will move on to the software. Okay, because the art of developing a mathematical model is not that much easier task. So idea should be scribbled, whatever that comes into our mind manually. Okay, depending on time to time, if you want to change the constraint or objective function according to the nature of application, we can do it. Then finalize the model, then you implement in the software solution. Okay, so here let n represents the number of products to be manufactured. So in this case study, there are 2 products, P1 and P2. Let m be the number of machines used. Okay, so in this case study, we follow 2 machines. Okay, so LP model has a few basic elements which are listed below. Okay, so these are the various parameters we are going to see in the next future consecutive slides. So decision variable, okay, that is the first and foremost thing in a mathematical construction. We want to understand what is decision variable. So this will try to support any linear optimization problem to overcome the hurdles that will try to achieve the goal function. That is a particular course of action. Okay, let us take for example x1, x2 or the production volume. So you don't know the optimal production volume to be planned. So using linear optimization with the help of Lingo solver, so which is best, x1, x2, which production volume considered to be the best. So through that, you will try to solve and find out the final optimal solution, okay, for maximizing the production volume of the product. Okay, so the decision variable generally denoted as x1, x2. Okay, objective function coefficient. So it is a constant which tells about the profit per unit or cost per unit of the product, generally denoted as C1, C2 up to C suffix n. Okay, right? For the product model P1, P2. So let us understand with an example. C1 be the profit per unit for the product model P1. Okay, similarly, C2 is nothing but profit per unit for the product model P2. Okay, then objective function, if it is said to be a benefit related objective function profit, then you have to use a maximization type. If it is a cost related, then you have to go for minimization type. Okay, so you want to level the resource, adjust the resource within the tight bound limit constraint. So you have to go for minimization type. Okay, the general notation for objective function. Okay, if it is economical, go for maximize Z is equal to C1 is nothing but the unit cost of the product. Okay, combined with the decision variable X1. Okay, where plus C2 into X2. So this is the general notation for our problem. So the precise, the objective function, the proposed objective function given in this form. So C1 into X1, since there are two products, so what is the unit cost for the two product model? That is represented by C1 and C2, followed by decision variable, unknown decision variable X1 and X2. So I don't know what is the total maximum profit. Okay, so I introduced two decision variable X1, X2, along with the constant. Okay, so this 250 is the unit cost for the product model P1 and P2. Okay. Then technological coefficient. This is related to how to build up the constraint technological coefficient. So here in our problem, the technological coefficient is nothing but the set of the machine availability per week. So per week, what is the maximum the working hours? So that is denoted by A suffix ij, general notation, Aij, where I represents the amount of resource, that is a material, amount of resource, raw material, that have to be allocated in a particular machine to do the activity, production activity. So that varies generally from 1 to n. Okay, right? Specific representation A11, A12, like that we can able to represent the technological coefficient. Then resource availability. Okay, so this for this inventory planning and control. Okay, so depending on the various period, the month, during the various planning period, let us take B suffix I is the general notation. So B1, so for example, you take month of March. Okay, B2, month of April. So what is the amount of resource which are to be scheduled during the planning period? Okay, so we can say resource availability. Okay, so limiting criteria, B suffix I. Set of constraints. So as I've already told you somewhere in the previous slide, it is a kind of a limitation or a restriction to achieve the objective function. Okay, at various levels when you are carrying out the activities at different levels. Okay, so the general notation which is given here for the constraint, where A11 is nothing but the process time of the product model P1 on milling machine, okay, followed by X1, plus A12 is nothing but the process time of product model P2 on same the milling machine, okay, followed by the unknown decision variable X2. It goes up to nth term, then less than or equal to the maximum available working hours per week, that is represented by B1, less than or equal to constraint. So here we want to use less than or equal to constraint. Okay, so where B1 is the resource availability. Okay, right? So non-negativity constraint. So each and every decision variable in the linear programming model must have a non-negativity constraint. So this is ideally represented as x1 comma x2 are greater than or equal to 0. Okay, right? So let us see the complete model framework. So whatever I shown you in the data table, so based on that, the model construction has been framed out. So let us refer the data table again. So objective function, how to construct an objective function. Okay, maximize is that. So 250 is the unit profit, okay, for the product model P1. So 250 X1 plus 400 into X2, okay, right? So that is my objective function, which I wrote here. That's subjected to set of standard constraints, okay? So 2x1, that is 2x1 is nothing but the time availability, that is the process time availability on the corresponding machinery, okay, to process the two batch of products P1 and P2, okay, that must be less than or equal to the maximum available time per week, okay. So this is already given in the table, the data table, the case study itself. Okay, so 2x1 plus 5x2 less than or equal to 200. So the same thing we want to construct for the drilling mission, the resource constraint for the drilling mission. And then non-negativity constraint. So now we want to solve this model using lingo formulation. Rewrite the same model, okay, but when you are going for the software, so you want to use certain standard syntax, max, okay, so capital M, okay, because even the certain individual data, so that will take it as an infeasible value. If I put small m, I cannot able to run the output, okay. So I want to use the standard objective function max, okay. So the remaining as usual. It's like a notepad. The workbench seems to be like a notepad. So we can edit, okay. So the structure of the mathematical model and using solver option, okay. So we can able to read the output that is given in the next line. So the maximum, the total profit for both the product batch P1 and P2, okay, combined together as a net profit 20,500 rupees. That is the total profit given by the solver, okay. So this is a global optimal solution obtained, right? So what is the iteration? The solver takes 2 cycles or 2 iterations within the minimum time, that is 7.28 seconds. So this simple model, okay, so that will take 7.28 seconds to come out with the final solution, okay, right? And these are the number of variables, the constraint, the historical thing, data which are defined here. And on every iteration, so that will update the value of the objective function, okay. So I think remaining half of the information has not seen visible, okay. So based on this iteration, so we will try to find out what is the best objective function value, okay, right? So in simulation we cannot see all these things lively, okay. For that only mathematical approach is essential to compare the simulation result. So these are some of the future scope in optimization. So simulation of warehouse space allocation. Okay, this comes under inventory optimization of a warehouse space management system. Okay, so I can use a virtual 3D simulation modeling softwares like Enterprise Dynamics. Okay, right. So using that, I can able to find out what is the most minimal space at which I can stock the material. Okay, I can able to cut down the inventory holding cost. Okay, right? So these are various optimization approach. Or I want to have multiple warehouses, so I can do optimization by virtual simulation. The next scope, surveillance and warehouse, security system in warehouse. Okay, using RFID or barcode technology. Okay. So the final takeaway of the today's workshop. So at this juncture, we come to know that the optimization is a technique or methodology that can be applied in a real world, a practical situation to increase the productivity of an organization. The linear optimization tool is one such technique which helps the industrial management to predict the demand, the expected output by using the so-called software application like Lingo Solver. So with this, I thank the organizer and also the participant for sharing their busy schedule the weekend. So thank you one and all. If you have any queries, you can ask.
Thank you, sir. Thank you for your informative session. Now, the participants can ask any questions or interact with the speaker by unmuting themselves. The provision is given to you. Any queries, please?
So make use of this platform. So any clarifications or can directly speak with today's speaker. Just unmute yourself. That option is provided.
But one thing I can say, but these kind of models are practically not used in industry, but I strongly recommend that if an industry has an opportunity to use such theoretical quantitative models using software, so they can able to very well plan themselves within a reasonable point of time, okay, to adjust the real constraints. But none of the industries are not using this, the Lingo solvers. Okay.
Yes.
Lingo is not alone only the mathematical programming softwares. There are many other things like Torah, Lindo. These are some other same function features. Okay. So you can freely download it. Okay. So it is not a paid software. We no need to pay anything. So freely downloadable software, open source software. But people who are doing research are highly getting benefited using this optimization, numerical optimization. So this we can say business analytics, that is operation research, comes under this category, business analytics. Yes, I think Vishwash Shetty has asked one question. Can we use this technique in 3D modeling software while designing? Yeah, definitely, sir. Okay, first we have to create a simulation model, a blueprint, and then to validate the efficiency of the simulation 3D model, we have to use the numerical approach to compare the results. Okay, definitely. Simulation alone will never give you the final convincing answer for any solution, for any engineering issues. We should have a quantitative modeling in form of a structured equation. Any other queries?
Anybody else? I hope Vishwas, you got your answer.
Because simulation is a black box. If you give an output, if you give input, it will give an output. Okay, we cannot analyze much on simulation, but numerical optimization, stage by stage, we can deal with the data numbers. Based on that, we can able to give the best result. So that is why these are called as an optimal package. Yes. Yes.
Anybody else? Yes, Suhas.
Good afternoon, sir.
Yeah.
Yeah. Sir, I have a question. Can this solution be useful for some of the miscellaneous problems like in ISROs and all?
Yeah, definitely, sir. For space management, satellite launching, same thing we can do. So we should know the objective function and the constraint. Okay, right?
Yes, sir. Thank you.
But lack of knowledge, the industry peoples are having some lack of knowledge on theoretical, quantitative techniques. That is the only trouble with us in India. But scope is there.
But what is the reason why most of the industries they are not implementing it? What is the main reason?
So on my own personal experience, when I'm doing my ME Industrial Engineering, the third semester, I went and approached for Sundaram Fastness in Madurai. Okay, if I did my project in production scheduling and sequencing using same numerical data analytics, right? So they asked me a question, the first question, how this theoretical quantitative model supports industry, in what way. As a student during that point of time, I was new to the concept. Okay, so I was somehow managed the situation, but it was not convinced by them. So they told that the theoretical models and all will not support for the practical situation. So this was the resistance by the industry people. So if any new algorithm or the theoretical concept, so which academicians are trying to introduce, so normally there is a common human nature, resistance to change. So whether it will spoil the industry climate or that will bring loss to the industry, how far this kind of thing will be profitable, they will consider in the case of money, material point of view. That is not wrong. I am not criticizing them, but this is a kind of gap which arises. Probably in future, I hope that the industry should coordinate with academicians to use, to get practice well versed with this kind of numerical modeling techniques.
And the software is available free, you told. So, so any person can learn how to use the software with their data and all.
Yeah, definitely, sir. A person who is flexible with the manual knowledge on linear programming, so you can solve the problems whichever given manually in the book or by downloading the software, you can solve it manually. Okay, it is just considered to be we don't need an expert. We ourselves can learn.
That is what it is required. Yeah. So even those who are doing their projects or research scholars also, they can make use of this the software to optimize their the data. They can input their data.
There are many textbooks like Hamdi Taha. Many operation research books are available. Okay, so you can take one case problem, solve it in Lingo Solver or Lindo. So see how the output comes, measure the theoretical answer and the answer given by the software. What is the variation? So that is the analysis part. In that way, we can learn on our own self.
So is there any variation and what percentage of variation so you have come across with the case studies?
So for example, the same problem I am using graphical method. So probably 0.12% variation will be there. Okay. Okay, for this problem, I'm getting 20,500 is my net maximum profit. Okay, so if I solve it theoretically, it will be 21,000 or 22,500 difference, marginal difference. Method, use of method. Here I use software instead of theoretical approach.
Fine. So,
Good morning, sir. Hello.
yes, Arun Kumar, you can speak.
Sir, have you compared with any other software? What is the accuracy? Since there are plenty of optimization technique softwares are there.
I can share my experience, sir, in my PhD, the research on assembly line balancing. The same software I used for considering the objective of minimizing the number of assembly station subjected to the set of resource constraints, cycle time constraint. So there I compared my Lingo solver with the genetic algorithm, okay, with approximation. Algorithm always we can say it is a near approximation technique. So I compared the Lingo solver with an algorithm and proved finally the mathematical modeling, the results given by that considered to be more efficient. So based on my past experience, I'm telling this. And also it has got some limitation, mathematical modeling software. Only small, medium size problem, depending on the memory data, the space, we can solve. Okay. Large size problems we cannot able to solve using Lingo. Algorithm is one of the best choice. Okay. Like a global heuristics like genetic algorithm, Ants colony optimization algorithm. These are all some of the preferences. Okay. So that is one of the negative side of mathematical modeling. Only small and medium size problem we can do it.
Do it, yeah. So any
Thank
more
you,
questions? Any more questions from anyone? Or you can share your feedback also about the session if anybody is interested. You can share your feedback too.
What are the advantages of this Lindo software compared to other Tora or any other software, sir? Is there any specific advantages other than the free availability?
Advantage, there is no such a specific advantage. Functionality, all are same, but only software configuration that is different. But I am experienced in using Lingo only, sir, to be very frank. But I heard about Tora, but I am not much expert in that.
Like user friendly, so which is more having more user friendly,
Yes,
something like that.
Yes, sir. Yes, sir. It is more user friendly. I told you, no, sir. Expert third person is not required.
Yes.
As a researcher, we ourselves can feel and experience. We can learn.
Yeah. So anybody want to share your feedback? You can share it, or else we'll move. Prashant, you proceed.
Thank you, sir. Now I request Dr. Ramachandra Siji, the Managing Director of Sanathana Research and Training Institute, to summarize today's webinar.
First of all, let me thank today's speaker, Dr. P. Sivasankaran, who has agreed to share his the knowledge today in our platform. Once again, I thank him for accepting our invitation and sharing his knowledge with a lot of examples. And today's topic we have selected optimization techniques for engineer. There are a number of the optimization techniques. Normally we use different domains, like we mechanical engineers, we use different type of techniques. Like other domains also, they will use different types of techniques. And the speaker has started with the optimization introduction he has given with very good example, vehicle body frame example he started with. So, and he has also given what are all the essential features of optimization, the problem if you consider, like economical objectives we have to consider, as well as the technical objectives also. And next he highlighted why optimization is necessary. So with example, he has discussed why we require optimization techniques for our engineering problems, and he has given in detail about the guidelines which are required, or optimization steps, how to do optimization, various steps involved in that. He has given in detail, and later he has given the elements of optimization problem. So with example, he has explained, and optimization by mathematical model. So linear programming example he has taken, and different properties of linear programming model he has discussed, and various literature he has discussed, who and all have worked on this particular the optimization technique, and which particular application they have worked. All those details he has given, and he has taken the case study to explain this optimization technique, how we can implement or develop this optimization technique with two products he has taken, P1 and P2, and he has given a complete details how to develop a linear programming model using a Lingo package, so which is a free available software where we can make use of in our the projects or research work and all, and including what is the future scope with in optimization field where we can apply this, and a lot of queries raised by the participants also he has cleared it. So optimization, it is required everywhere, okay, either to maximize or minimize that it is required. So it is left to us how we'll make use of this optimizations techniques, either to increase the profit or reduce the waste, that is either minimizing or maximizing some parameters and all. So everywhere it is required. So we engineers, we have to develop such kind of techniques so that we can increase the profit or decrease the either the cost involved to manufacture whatever it is. So we hope the purpose which is for organizing this particular national webinar on optimization techniques for engineers. So you have you gathered some information. So surely, so you're going to implement these techniques in your research work. So with this, so I'll summarize. I'll summarize this. Summarize this the entire the webinar. So over to you, Prashant.
Thank you, sir. Now it is the time to express our gratitude. Dr. P. Sivasankaran, Associate Professor, Manakula, Vinayagar Institute of Technology, Pondicherry, for accepting our request to be the resource person of today's webinar and for delivering a very informative and wonderful session. Thank you very much, sir. I thank Dr. Ramachandra CG, the Managing Director, Sanathana Research and Training Institute, and Dr. P. Raghavan Prasad, MD, President, and Dr. Dinesh and Sri Dinesh Kumar DK, the Secretary, Rotary Club of Mysuru West, for their involvement in organizing this webinar. I also thank Sri Lokesh CG, President, Dr. Shantraja Aras, and Srimati Bhagya Gopal, Board of Trustees, Sanathana SAMPRATHISHTANA, for their support extended in organizing this webinar. Finally, I thank all the participants for your support and active participation in this webinar. Thank you. Thank you, one and all.
Thank you. Thank you, sir.